Picture this. You're running about 5 minutes late for a dinner reservation.
Oh, I know this feeling.
Right. Or maybe you're trying to make a really important meeting downtown. You arrive at the street and it begins. The prowl.
The dreaded prowl.
You're circling the exact same city block just endlessly. You're gripping the steering wheel, scanning the street, just hoping against hope that you'll spot some reverse lights and a spot will miraculously open up.
Meanwhile, the traffic around you has slowed to an absolute crawl.
Exactly. Your fuel tank is draining and your stress levels are just spiking. We have all been there. It feels like this deeply personal inconvenience that the universe just designed to ruin your day.
It really does feel personal in the moment.
Yeah.
But the truth is...
It's not.
No, it's not. While you're sitting there frustrated, what you're actually experiencing is a massive cascading systemic failure. That simple, everyday act of looking for a parking spot is a trigger for some of our largest urban crises. And that's exactly what we're digging into today.
Welcome to the Deep Dive. Our mission today is to completely flip how you think about parking. We're going to explore how a seemingly mundane urban annoyance, finding a curbside spot, is actually a massive, totally untapped gold mine of data.
A gold mine that cities are largely just ignoring right now.
Exactly. We're basing today's conversation on a really fascinating project challenge proposal. It's titled Smart Curbside Parking, using the Favorite Insight Framework. It's this incredible look at how turning dumb concrete into intelligent infrastructure could completely transform how we move through our cities.
And joining you to unpack all this is me. I'm really excited to get into this one.
Yes, our resident expert is here to help us connect the dots on the technology, the economics, and the reality of making this happen.
Because when most of us think of parking, we literally just think of gray pavement and faded white lines. But those empty spaces, or, well, those stubbornly full spaces, are holding operational secrets that city planners desperately need if they ever want to fix urban mobility.
Okay, let's unpack this. Because to understand the solution, we have to look at what's currently going wrong. When curbside parking is left completely unmanaged, or even just poorly managed, the ripple effect is staggering.
It really is.
It isn't just about you wasting your precious time. The endless circulating directly creates major traffic congestion. The proposal notes that if you look around during rush hour, a huge percentage of the cars in front of you aren't actually actively commuting.
Right, they're just hunting for a place to stop.
Which is wild to think about.
It is wild. And that naturally leads to increased carbon emissions, wasted fuel, and a generally degraded urban environment. But there's also a massive economic angle here that often gets overlooked. Local businesses take a huge hit from uncertain parking.
Right, because if you know you're going to spend 20 minutes hunting for a spot just to grab a quick cup of coffee or pick up a takeout order, you just don't go.
Exactly. You abandon the trip. Or you drive out to a big box store in the suburbs that has a massive guaranteed parking lot.
So the local downtown economy just suffers.
It bleeds revenue. And on top of the economic hit, you have the safety hazards. When people get frustrated by the prowl, they make bad decisions.
Oh, yeah. They park illegally.
They block pedestrian walkways, they idle in bus lanes.
And they double park and just throw their hazard lights on, like if it makes it okay.
Right. It creates absolute chaos on the street level.
And here is the wildest part of all of this. According to the source, curbside parking is considered one of the most underutilized sources of urban data in existence. The streets literally already contain all the behavioral information we need to improve mobility.
It's all right there.
The data is happening right in front of us, but it's just evaporating. It's rarely captured, rarely analyzed, and almost never turned into actual municipal decisions.
It's a glaring missed opportunity. And that brings us to the core solution we're looking at today. The overarching goal of the Favorite platform is to transform these ordinary streets into intelligent parking zones.
How does it actually do that?
Well, it pairs cloud-based IoT.
The Internet of Things.
Yes, IoT with advanced video analytics. So instead of a static piece of pavement that a meter maid maybe walks past once every 2 hours, you have continuous, intelligent monitoring. Cameras observe the spaces, identify when a vehicle is present, and measure the exact duration of the stay.
But getting to a point where a city can actually use that data requires a serious roadmap. I mean, you can't just slap a bunch of cameras on light poles and hope for the best.
No, that never works.
That's where this specific favorite insight framework comes in. It's structured into 5 distinct layers. And what I love about this approach is that it starts with a layer that has absolutely nothing to do with technology.
Yes, layer 0.
Right. Layer 0 is all about intent and context.
And honestly, layer 0 is where most smart city projects either succeed or completely fail. The framework dictates that a good system has to define the real problem before a single byte of data is collected.
We do have a bad habit in tech of hoarding data just to have it.
We really do. But here you have to establish the purpose. The primary challenge isn't that we don't have enough cameras. It's the lack of real-time visibility into availability and duration. Drivers don't know where the spots are, and authorities can't detect oversteers efficiently.
Which means before you even turn a camera on, you have to sit down and define what normal actually looks like for your specific city.
Precisely. You have to establish baseline parameters. Normal behavior means a vehicle is occupying a designated space within the allowed time limits. It means the zone is being used properly. And crucially, it means there's adequate turnover.
Turnover is key.
Oh, absolutely. A healthy commercial street needs turnover, so multiple drivers can use that exact same piece of real estate throughout the day.
And once you agree on what normal is, you have to define the risks, the anomalies. Things like overstaying, parking in a loading zone, or that low turnover that strangles local businesses. So layer A0 gives us our philosophy. But philosophy doesn't manage traffic. You have to actually capture reality on the streets. Which brings us to layer 1, the data foundation. This is the hardware, the eyes on the street.
Right. And it's important to understand how sophisticated this hardware has become. We're talking about roadside video analytics cameras equipped with AI-based object detection.
But a common question here, and I had this thought too when I was reading the proposal, is how does the system know the difference between a car that is actually parked versus a car that is just stuck in gridlock next to the curb?
That's a great point.
Because if traffic is backed up, you definitely don't want the system registering 50 parked cars right in the middle of a travel lane.
Exactly. And that's where the AI object detection comes in, using spatial mapping and dwell time thresholds. The system essentially defines a digital bounding box over the actual parking space.
Just drawing an invisible box on the street.
Right. When a vehicle enters that specific box, a timer starts. If the car is just slowly rolling through or it stops for 30 seconds because of a red light, it's ignored.
Okay.
But once it hits a specific threshold, say 3 minutes inside that bounding box, the system officially registers it as a parking event. It generates a precise to the second timestamp for the start of the event and another one when the car finally leaves.
But think about all those cameras generating all that data, sending high-definition video feeds of thousands of cars 24/7. That sounds like a massive bottleneck. And honestly, a bit of a privacy nightmare.
What's fascinating here is how the architecture actually solves both of those problems simultaneously. It uses something called edge computing.
Edge computing.
Yes, the cameras on the street are edge devices. They process the video footage locally right there on the pole.
Oh, wow.
Yeah, they aren't streaming raw, live video of you parking your car to some guy sitting in a dark control room.
That's a relief.
The AI analyzes the frame, determines the spot is occupied, and then simply sends a tiny packet of time series data. It's basically just a line of text saying, Spot 42 is occupied at 10:04 a.m.
Oh, that makes so much sense. So it's sending the insight, not the actual video.
Exactly. It uses secure IoT protocols to send that lightweight time series data up to the favorite platform, which acts as the scalable cloud brain. This is crucial for privacy because the data is essentially anonymized right at the source.
And you aren't overloading the city's bandwidth.
Right. The proposal emphasizes that having this rock-solid, trustworthy data foundation at layer 1 is everything. If the data is flawed here, every single decision you make down the line is going to be wrong.
Here's where it gets really interesting, because once you have that secure foundation, you can move up to layer 2, descriptive insights. This is where the invisible data grid suddenly becomes visible. It's the phase where a city can finally see the now.
Yes. For the first time, city operators aren't just guessing. They're looking at intuitive dashboards filled with real-time widgets and charts and heat maps.
It's just a full command center view.
Imagine a city planner sitting at a desk and being able to see exactly how many available spaces there are on a specific commercial avenue at this exact second.
They can see the occupied spaces, the average duration people are staying, and the historical utilization trends from the past week. It's total situational awareness. But the descriptive layer isn't just for the bureaucrats in City Hall, right? This is the layer that actually touches you, the driver.
That's the beauty of it. Because the data is real-time and cloud-based, that availability status can be pushed directly out to the public.
To our phones.
Exactly. You could check a mobile app before you even leave your house. Or you could look up at a dynamic digital signboard as you turn onto a street and see exactly where the vacant spots are.
That is huge.
It completely eliminates the blind prowl.
Yeah.
You aren't hoping for a spot anymore. You're navigating to a known vacancy.
I know so many people who would pay good money for that app on a busy Saturday. Just knowing the spot is there lowers the blood pressure immediately.
For sure.
But as satisfying as it is to know what is happening right now, the framework pushes us to dig deeper. Which brings us to layer 3, diagnostic insights.
Knowing what is happening is great for the immediate moment, but layer 3 is about diagnosing the why. Why are certain streets always gridlocked while the next block over is completely empty? Why are turnover rates so low in specific retail zones?
And this is where the cross-analysis comes in, right? You take the parking duration data and you cross-reference it with other things like zoning data.
Right. And this completely changes the paradigm of city management. I'll give you a real-world example. I remember a few years ago, I got a parking ticket on a Tuesday morning at 10 a.m. The street was completely empty.
Oh, no.
There was no traffic, no bustling businesses open yet, but the sign said 2-hour limit, and I was there for 2 hours and 15 minutes. It felt completely arbitrary. Why was that rule even there?
Probably because someone complained 10 years ago and they put a sign up and just never thought about it again.
Exactly. Historically, city parking management has been incredibly reactive. It's a system built on blind reactions to the squeakiest wheel. Someone calls their city council member to complain that their street is always blocked, so the city drops a 2-hour limit sign there and sends an enforcement officer out.
But with Layer 3 diagnostic insights, authorities can finally base their decisions on clear, empirical evidence.
Yes, they can look at the data and say, wait, the turnover rate in this commercial area is actually too fast. People don't have enough time to shop. Let's extend the limit.
Or they can pinpoint the exact streets that have the most frequent parking violations and realize that maybe the signage is just confusing or the zoning needs to be updated. It moves the city from guessing to knowing.
If we connect this to the bigger picture, that shift from guessing to knowing is what allows a city to graduate to Layer 4, predictive insights. This is where you stop looking at the present and you start seeing the future.
Predictive modeling is always where these tech frameworks start feeling like science fiction. But it's really just math, right? You capture all this historical behavior over months and years, and I just let the algorithms run.
Exactly. It's pattern recognition. By analyzing historical patterns, factoring in things like time of day, day of the week, seasonality, and even weather, the system's predictive models can accurately forecast peak parking demand before it even happens.
The operational efficiency of that is wild. The city can estimate what parking occupancy is going to look like during a busy holiday weekend, or if there's a massive concert downtown, they can even predict the risk of illegal parking activity.
Think about what that means for resource allocation. If the system predicts a 90% probability of severe parking shortages and high illegal parking risk in a specific entertainment district on a Friday night,
they don't have to wait for the chaos to start.
Right. They don't have to wait for the complaints to roll in. They can proactively deploy enforcement teams to those high-risk areas ahead of time. They can blast out notifications to the public apps warning drivers about expected shortages,
nudging them to take public transit or park in peripheral lots before they even leave their driveways.
Exactly. It's proactive management instead of reactive firefighting.
Which leads us perfectly to the absolute peak of the framework. Layer 5, prescriptive insights. This is where the entire system actually goes to work. It's not just predicting what will happen, it's automatically executing actions to optimize the grid.
Yes, at Layer 5, the data actively drives automated decision-making. The system takes the human delay completely out of the loop.
So, practically speaking, according to the source, this means automated alerts. The moment a vehicle exceeds its time limit, an alert is pinged directly to the tablet of the nearest enforcement officer.
No more walking the block with a stick of chalk, checking tires.
Right. The officer knows exactly which spot has a violation.
It creates hyper-efficient enforcement, which I admit sounds a bit intimidating, but it ensures the rules are actually applied evenly, which drives the turnover that businesses desperately rely on. But the most powerful prescriptive action, and the one that really changes urban economics, is dynamic pricing.
Okay, let me play devil's advocate here for a second.
Go for it.
When people hear dynamic parking pricing based on real-time demand, what they actually hear is the city is going to surge price my parking spot, and parking is just going to become a luxury that only wealthy people can afford. Doesn't this just punish the average driver?
It's a totally valid concern, and it's always the first thing people worry about. But the economic theory behind dynamic pricing isn't about maximizing profit. It's about balancing the load across the city grid. The goal of dynamic pricing is to ensure that there are always one or two open spots on every single block.
So you're managing the demand curve, not just gouging people.
Precisely. If a highly desirable street outside a popular theater is at 98% capacity, the price on that specific block goes up. But crucially, the price on the underutilized street, just 3 blocks away, goes down.
I see.
It uses market forces, driven by perfect real-time data, to nudge drivers who are willing to walk a little further to those cheaper spots. It spreads the density out.
It distributes the pain, basically.
Right. And by distributing the density, you eliminate the prowl. You eliminate the traffic congestion caused by everyone fighting for the exact same 4 spots right in front of the door.
So while you might pay a little more for the premium spot, you're buying back the 20 minutes you used to spend burning gas and circling the block.
Exactly. Creates a fluid, balanced system.
So what does this all mean? We've gone through this massive architecture. We've talked about AI edge cameras, time series data, diagnostic cross-analysis, predictive modeling, and dynamic pricing. But why should you, the listener, care that this massive invisible data framework is quietly running in the background of your city?
You should care because, ultimately, it is a blueprint for a significantly better quality of life. The broader impacts here touch almost every aspect of your daily reality. By ending the parking prowl, we're talking about drastically reduced traffic congestion. That means your commute is faster, your blood pressure is lower, and your streets are just safer for pedestrians.
And from an environmental standpoint, reducing the time cars spend idling and circling means a massive drop in fuel consumption and carbon emissions. It means measurably cleaner air in dense urban corridors.
And let's bring it back to the local businesses one more time. When parking is predictable, when turnover is managed effectively, commercial areas become highly accessible. Shops and restaurants thrive because their customers aren't abandoning their trips out of sheer frustration. It transforms the curbside from a chaotic free-for-all into a smoothly functioning economic asset.
It's incredible to think about the evolution of a simple piece of concrete. To briefly recap our journey today, we started with that universal, everyday headache of endlessly circling the block. And we've seen how a structured framework, starting with clear intent, building a secure foundation of AI video analytics, and layering on descriptive, diagnostic, predictive, and prescriptive insights, can entirely cure that headache. It takes the guesswork out of urban mobility and replaces it with trusted, automated, data-driven harmony.
This raises an important question, though. We've talked about the incredible benefits of this harmony. But if every single curbside space in a city is continuously monitored by AI object detection,
right.
If every time you pull over, your exact location, your arrival time, and your duration are flawlessly logged in a cloud database to map your behavior and predict your future movements, what does that mean for the anonymity and spontaneity of urban life?
That's a good point.
At what point does a beautifully hyper-efficient smart city start to feel like a city that simply knows a little too much about exactly where you are?
Wow, that is a heavy thought to leave on, but an absolutely vital one. We have to balance ultimate convenience with the reality of continuous observation. Thank you so much for joining us on this deep dive. We hope we've given you a whole new perspective on the invisible machinery of your city. Next time you finally pull into that elusive parking spot, take a look at the nearest light pole. You might just be participating in a much smarter data ecosystem than you ever realized. Catch you next time.